Continuing our lecture with strings, we're going to talk about arithmetic operators and just specifically addition because that's the one that really makes sense when using strings. Just some reminders here that when you are doing arithmetic operations with vectors, if I have a vector 1, 2, 3, and I add the number 2 to it, I can do that because this is a scalar. And then that will give me the result of a vector 3, 4, 5. I can also add vectors to vectors, 5, 6, 7, and this will give me the result 6, 8, 10. Now the thing to remember, of course, is that you can only do this if what you're adding to is a scalar, or if the vectors that you're adding are the same size. If you try to add two vectors that are not the same size, something like this, so let's do 5, 6, 7, 8, then you're going to get an error. And that holds true with strings as well. We're going to see some examples here where you can add a string to a scalar, something like this. You can add a string to a vector, something like this. You can add a string to a character, which would be the equivalent of a scalar, something like this. And you can add a string to a string, something like this. And all this works fine. However, if you try to add a string to a string that is not the same size, then you're going to get an error here. Okay? So let's look at these examples and to see what's actually happening with MATLAB. So let's just say I had some variable, I call it TECH, and I say that's going to equal uint8 of the string TECH. Now I did this example this way for a reason. This is a variable name because it has no quotes around it. This is a string because it has quotes around it. So now TECH is going to get the vector. Remember, uint8 is going to convert this to its ASCII equivalent, integer value equivalence. And so it's going to get the vector 116, which is the ASCII value for lowercase t, 101, 99, and 104. Okay, so that's what that's going to equal. Now if I come in here and I say A equals TECH plus 2, then what's going to happen is A is going to be 2 plus all these ASCII values. MATLAB is going, because you're doing addition, MATLAB is going to convert this to its ASCII equivalents automatically, because there's no way they can add the letter T to 2, so it makes sense of it by turning the TECH into its ASCII equivalents and then adding. So you do 118, 103, 101, and 106. And then if you were to do a char on this and actually look at these characters, then you would convert these characters back to their these ASCII codes back to their characters, and so you would get something V, G, E, J. Now a lot of times when you do this string type of math, things don't make much sense because, you know, adding 2 to tech just gets you V, G, E, J, which is not necessarily a string that matters. But there are times, and I'll show an example at the end of this, there are times when this does make sense. Let's continue on. So that's adding a scalar to a string. Let's now add a vector to a string. So let's say if we had E equals TECH plus the vector 1, 2, 3, 4. Well, that's going to give us this in its, because it's addition, it's going to give us, it's going to convert this to its ASCII codes and then do the element by element addition. So you're going to wind up with 116 plus 1, which is 117. You're going to get 101 plus 2, 103, 99 plus 3, 102, and then 104 plus 4, which is 108. Okay? And once again, if you did a char on this and converted it back, you're going to get, you know, the string U, G, F, L, which really doesn't have any significance here. All right, so that is a string plus a vector. Now let's look at if we do a string plus a character. Now it's once again going to convert both of these to their ASCII equivalent. So that's like saying what is this vector plus this scalar. And so when you do that addition, you wind up with 213, 198, 196, and 201. Which now, if you do a char of this, you now are way up into the upper the extended ASCII codes, and you get some crazy characters, which we'll see when I do the MATLAB demonstration. But all of these are well outside the normal, the basic ASCII range, which goes up to 127. So these are your extended characters, and we'll see that in a second. Lastly, I like to show what happens when, let me introduce another string here. That's the variable buzz, and it's going to hold the ASCII values for the string buzz, and that's going to give us 98, 117, 122, 122. And then if I did M equals the string tech plus the string buzz, I am going to wind up with the vector 214, 218, 221, and 226, which once again, if I did a char on this, it's going to give me, these are well outside the normal ASCII range, and these are going to give me some of the extended characters. Okay? All right, let's go over to MATLAB and look at this. So here I have all of this set up, and I have the breaks in here, so let's run this. Stepping through, I set the variable TECH to uint8 of tech, so I changed the string TECH, the string tech, into its ASCII equivalents, which there they are. Now A equals the string tech plus the scalar 2, which just adds 2 to each one, which you see here, 116, 101, 99, and 104 plus 2 gives this vector here, A. And then if I do a char on that, I get VG, EJ, which are just the all the letters that are 2 up in the alphabet from TECH. Then I come here and I do E equals TECH plus the vector 1, 2, 3, 4, which if you take 116, 101, 99, and 104 and add a 1, a 2, a 3, and a 4, this is what you come up with. Then I do TECH plus A, which is, well, excuse me, then on line 15, I convert this vector to its characters, and I get UGFL, which doesn't really mean anything. If I do I equals TECH plus A, it converts to 8 and 97, and so you wind up with I being this vector. Once again, converting that char throws you into the extended ASCII, which you get crazy characters like this. here I show that buzz uint8 is this vector, and then when I add TECH plus BUZ, BUZZ plus buzz, I wind up with 116 plus 98 is 214, 101 plus 117 is 218, 99 plus 122 is 221, and 104 plus 122 is 226. So I wind up with this, and then I do the char, and I'm in the extended ASCII character set. What I want to point out here is that you can add characters and strings. What MATLAB does is convert it to its ASCII equivalent to do the addition. So next up, I'll show a somewhat useful example of this. One useful application of adding a character to a string without running into the extended ASCII code or even Unicode is in changing case. So if I say t equals uint8 of, once again, the string TECH, that's going to give us t equal to the vector 116, 101, 99, and 104. And then if I say DIFF equals the difference between lowercase a and uppercase a, that will give me how far the lowercase and uppercase values are apart. And that actually is the number 32, which also is the ASCII code for space, but we'll get back to that in a second. So now if I come in and say a equals lowercase TECH minus the difference, or DIFF here, then I'm going to wind up with adding 32 to each one of these lowercase values. Well, if I do that, I'm going to subtract 32 from each one of these lowercase ASCII values. If I subtract 32 from each one of these lowercase ASCII values, I wind up with the vector 84, 69, 67, and 72. Well, if I do a char on that, I actually wind up with the vector or the string capital TECH. So by doing this subtraction here of the value 32 from lowercase letters, I actually convert them to uppercase letters because I'm taking the ASCII down from the 97 122 range back down to the 65 90 range. And so that is a very useful thing. Also, I don't necessarily need to use the diff here because I understand that 32 is the ASCII value for space. So I actually could do something like b equals tech minus a space here, and this will convert TECH to capital TECH, because this will, once again, as we asserted before, this will convert to 32, this will convert to its ASCII values, this subtraction will happen here, and then it will be converted. And we'll see that when I go to the MATLAB example. Also, it goes the other way. Let's say if I define capital T equals uint8 of capital TECH, then that's going to be the vector 84, 69, 90, 67, and 72. And so now if I come in here and say that, I don't know, E equals capital TECH plus space, now this is going to add 32 to every value in this vector, and if I did a char on E, it would actually wind up being lowercase TECH, because by adding 32 to each one of these, I'm going to get the vector 116, 101, 99104, which is, as we see up here, lowercase t-e-c-h. And so this adding the space and subtracting the space from uppercase and lowercase letters allows you to switch cases between the two, and so that's sort of useful. Showing this in MATLAB, on line 7, I show the ASCII values for t. On line 8, I show the difference between lowercase a and uppercase a. On line 11, I make that subtraction from difference, and that's the ASCII I get, and I turn that ASCII back into characters. On line 12, which you can see we've converted TECH, the string, to capital TECH. I do it again on line 14, but instead of using the value 32 or the variable that has the variable diff that has the value 32, I actually use the space character, and you can see it works just the same. Uppercase, I show the ASCII values for uppercase TECH on line 18, and on line 20, E equals uppercase TECH plus the space, which will convert that back to the ASCII values for lowercase TECH, and I show that using a char on line 21 with variable f.